Okay, welcome back to economics class session number 1 today. And listen carefully. We completed one textbook termed microeconomics. All those chapters completed clearly. And we are going back to our statistics textbook. 3 more chapters want to complete. Okay, so we are starting today the 6th chapter, measures of dispersion. Clear? Okay, might you know the name of the term, disperse? What do you mean that? Spreading, right? Or not, disperse, let it. Okay, so measures of dispersion. Why we want to learn this? What are the importance of this dispersion there? So already in the previous chapter, we studied about the measures of central tendency. Measures of a central tendency. In simple terms, we know that we studied to find out the averages. Find out the average, right? Yes or no? Mean, median, mode. Mean, median, mode. But averages in statistics, there are some limitations. Can anyone tell that? What are the limitation of these averages? Limitations. Limitations of using averages. Anyone? Speak about that. What do you know about
Doesn't
that?
show the whole data, only the average.
Definitely. Okay. So we are unable to find the exact feeling of an individual or exact digits that related with a particular individual. We are unable to find it. Clear or not? Okay. For example, I can say that. Okay. For example, we can take an Abdul today. Abdul ate 6 meals for 3 days. 6 meals for 3 days. Now, what is the average number of his meals? What is the average number of meals per day?
2.
2, right, 2. So is that sufficient for an individual? Is that sufficient for an individual? What's your answer? Is it sufficient or not? Okay. Okay, almost we can think so we can say. So there's a saying in Sanskrit there. Okay. A person those who eating one time is yogi, right? 2 times he is rogi. Rogi. I mean a patient. Okay. 3 times bogi, right? Means he want to eat more, he want to enjoy the things there. 4 times we'll say he's a drohi, enemy. Understand? Enemy for the humanity. Okay, like that. So 2 meals, okay, fine. We can think like that. Okay, so like this. Okay, he ate 3 meals one day, but no meal next day. What is the average? What is the average? 3 meals one day, no meal the next day. What is the average here? 1.5, right? So 3 divided by 2, 1.5. So 1.5, okay, somewhat fine, okay, no problem. But actually what happened here? One day he live without any food, right? Average doesn't show that. Average will not say that. Clear? But average told us 2 days are there. Each day 1.5, 1.5. But really what happened there? One day 3 meal, the next day no meal. Okay. So averages will not show such kind of precise data. It will not create. It will not give information like that. Is it clear? Clear. Okay. So there's a problem with average. It will not tell the exact or entire data properly. It will not express. Okay. So we need this method is basically termed as measures of dispersion. Okay. Dispersion. Okay. So introduction we are reading here. In the previous chapter, you have studied how to sum up the data into a single representative value. That's what the average, right? However, that value does not reveal the variability present in the data, the differences in that data. It will create the entire data into a single digit, and will not reveal the variability or differences between the data. In this chapter, you will study those measures which seek to quantify variability of data, the differences between the quantity differences between the data we are able to find by using this method, dispersion. All right. So here is an example. Observe here, 3 friends. So Ram, Rahim, Maria. So secularism is there. The people are from all three regions, right? Ram, Rahim, and Maria are chatting over a cup of tea. Okay, chatting over a cup of tea. It's a famous slogan by our Prime Minister. What is that? Chai pe charcha. Okay, chai pe charcha. It's a great idea, right? So discussions by drinking tea. So they are also chatting. Okay, over a cup of tea. During the course of their conversation, they start talking about their family income. Okay, they started talking about their family income. Ram tells them that there are 4 members in his family and the average income per member is rupees 15,000. 4 members in the family and the average income is 15,000. 15,000. Okay, so Rahim said that the average income of the is the same in his family, though the number of members it is 6. Okay, so Rahim also said the same. Average income of his family also 15,000, but there are 6 members in the family. Maria says that there are 5 members in her family, out of which one is not working. Okay, so in Maria's family, 5 members are there. Out of these members, 5 members, one he is not working or she is not working. She calculated that the average income of her family also 15,000. Okay, so you can see here. Okay, so in one family only 4 members are there, another one 6, next one it is 5, but their average income is 15. We cannot find the differences between income within these families, right? We can say or not? Impossible, right? Nothing, no informations are there. They are little surprised since they know that Maria's father is earning a huge salary. So Maria's father's salary is very huge. Then also the average income is same. How it happen? How it? What is the reason behind this? How it happens? Okay, they go into details and gather the following data. So they observe the entire data. Okay, they took the number of members and their salary individually. So 1, 2, 3, I mean 6. 6 is the maximum number of members in one family, that is Ram's family, right? So Ram's family only 4. Their income all together 60,000. So 12, 14, 16, and 18, 16,000. Okay, and that divided by the number of people in the, number of members in that family, that is 4. So 60 divided by 4, that is 15,000. Next one, Rahim's family, all are working and their salaries are different, 7, 10, 14, 17, 20, 22. Altogether 90,000, but members are in 6 in number. So it's 90 by 6. They got 15,000. Okay, Maria's family, the first person is not working. So salary is 0. Her father's salary is too high, nearly 50,000. Others 7, 8, 10. Again, altogether 75 divided by 5, you got 15. Clear? Clear? Okay, so the average alone cannot, or it will not say the differences between the income of the family members in all these 3 families. Cannot. We are unable to find it. Only one average data we will get, that's it. Okay, so do you notice that although the average is the same, there are considerable differences in individual income. So average income of all these 3 families are the same, but differences are there, perfect differences are there between the individual income in these family members. It is quite obvious that averages try to tell only one aspect of distribution, that is the representative size of the values. Underline that. So we can say that averages try to tell only one aspect. What is that aspect? The distribution, that is a representative size of the values. Representative size of the values, only that we are able to find. To understand it is better, you need to know the spread of values also. So that's what dispersion, spread of values. You can see that Ram's family, differences in income are comparatively lower. Come here, coming to the Ram's family, you can see income between these 4 members, his family, that is 12, 14, 16, and 18. There is no much differences between the income of the family members. Okay. In Rahim's family, differences are higher. Okay. In Rahim's family, we can see that there are huge differences are there, or comparatively higher than the Ram's family between the income of the family members. Coming to Maria's family, what is that importance here? The differences are highest. Knowledge of only average is insufficient. So only the knowledge about the averages, that is not sufficient. If you have another value which reflect the quantum of variation in values, your understanding of distribution improves considerably. So we want to understand the differences between the values or income of different family members. Here it is easy to understand the total issue here. For example, per capita income. So we know that what is per capita income? Per capita income. Per capita income. What is that? Per capita income. What is that?
Total income of a country.
What is national income, right? Okay, national income divided by the population, right? National income divided by the population. That's what the per capita income. So here you can see, consider this is the population of one country. Example, Ram, Rahim, and Maria. Okay, population. Consider this population. So Ram's country name is Ram. There are 4 people are there. The national income is 60,000. What is the per capita income here? 15,000, right? Clear or not? So national income divided by the population. So in India, the national income is high, but the per capita income is too less. Why? National income is a huge number. Okay, unable to write in on a single paper, it seems. That much huge it is. Okay, but per capita income is too less. Why?
Population size.
Of course, the population size. Huge population, right? So that's it. That's the reason. So per capita income cannot say the income of different people in the country, right? So in the country, Mukesh Ambani is there, right? Adani Group is there. Beggars also are there. Okay, higher middle class people are there. Lower middle class people are there. Middle income group people are there. Okay. So this average per capita income is there, means for Mukesh Ambani also 11,000 rupees, for me also 11,000 rupees, for a beggar also 11,000 rupees in the country, right? Understanding or not? That's what per capita income. It cannot say the differences between the income of a different individual in the country. Cannot say, cannot express that. Clear? So that's what the problem of averages. Problem of averages, it will not show the individual data. A measures of dispersion can tell you about income inequality. So measures of dispersion can say the differences between the income. Okay, thereby improving the understanding of the relative standards of living enjoyed by different strata of society. So if you're using the method dispersion, it will say the differences between the income of different individuals in the country. So easily we are able to find the different groups of people and their income level, and can formulate policies and programs for the development of such kind of people in the country. So dispersion is the extent to which values in a distribution differ from the average of the distribution. Okay, so write down, underline that. Dispersion is the extent to which values in a distribution differ from the average of the distribution. Okay, clear? Underline. To quantify the extent of the variation, to find out the extent of the variation, there are certain measures are there. So measures of dispersion, we are using 4 different methods here. What is that? Range. Quartile deviation, we studied already. Mean deviation, studied. Standard deviation. We can find out the range. We can find out the quartile deviation, mean deviation, standard deviation. All are examples for measures of dispersion here. Okay, clear? It is different than the measures of central tendency. Averages. Average will not show individual data. Okay, or individual standards. Apart from these measures which give a numerical value, there's a graphic method for estimating dispersion. Okay, clear? Not only this numerical method, we can use a graphical method graphical way to find out the dispersion there. Okay, range and quartile deviation measures are measures the dispersion by calculating the spread within which the value lie. Mean deviation and standard deviation calculate the extent to which the values differ from the average, right? So first 2 methods, what are they? Range and quartile deviation. Quartile deviation. Okay, that is showing the spread within which the values lie, the difference between the values in the whole range, the whole group. Okay, so mean deviation and standard deviation. Next one, mean and standard deviation Calculate the extent to which the values differ from the average. Okay, the difference between the average and the most highest value in that particular group. Okay, here measures based upon spread of values. Okay, measures based upon spread of values. Two things are there. We'll use two methods. One is range, other is a quartile deviation. Quartile deviation. All right, can we start? Okay, got this one? We're asking the importance of measures of dispersion. This is the answer. All together, we want to find out the essence of this things what we'll read. Exclude this example. All of the things should be there. Right? Clear? Okay. Moving for the first idea. So here you can see a caricature here. As the average temperature is all right, you must be feeling fine. Right? Head is in the microwave oven and other part is in the refrigerator. Right? So what will be the average temperature? Here think it is 100 degrees Celsius. 100 degree Celsius. Refrigerator it is 50 degree Celsius. Okay, what is the average here? What is the average here? Think the microwave oven temperature is 100 degrees Celsius, right? Okay, go for fridge. It is 0 degrees Celsius. Okay, refrigerator 0 degree because we are using to chill that, right? So 0 degree. So what is the average here? What is the average? Find out and say. Make it fast.
50.
What?
50.
Yeah, 50. So two things are there, right? Under the microwave oven and the refrigerator. So 2. So 100 divided by 2. Answer is 50 degrees Celsius, right? 50 degrees Celsius. So for an individual, okay, we are adjusting, we are able to live in 50 degrees Celsius. But the thing, the head part is in the microwave oven, right? Is able to live there. So average will not show that the real problem. Average will not show the real problem. So just to keep this idea in your mind there, okay? This caricature shows that averages are not enough to speak about the entire thing or entire thing. Okay, so here, first of all, we are understanding here, that is range. Already studied in junior classes in mathematics. Range R is the difference between the largest, that is L here, and the smallest value, that is S here in the distribution. Thus, R is L minus S. Largest data minus the smallest one. Okay, largest value minus the smallest value, that is R here, range here, right? Clear? Range is equal to L minus S. Largest value minus the smallest value. Largest value minus the smallest value, right? Okay, so going for some example here. Higher value of range implies a higher dispersion and vice versa, right? Clear? If the value, the highest value is a great number, just imagine a huge number, the dispersion also a huge. Okay, if it's a small one, the dispersion also small. Okay, so higher value of the range implies a higher dispersion, and lower value implies the lower dispersion. Okay, just observe that. Just keep that idea in your mind there. So going for an activity here. Okay, look at the following values: 20, 30, 40, 50, and 200. Calculate the range. Make it fast. Give me the answer, quick.
180.
Here, look here. Look at the following value. Calculate the range. So I said it only is 180. So here you can see 20, 30, 40, 50, 200. The highest value, what is that? L, largest one. What is that? 200, right? What is the smallest value? Smallest value. S, what is that? 20, right? So 200 minus 20, the answer is 180. 180. Got? That's what the difference between the lowest value and the highest value. It is 180. It is 180, right? Next question. You got that. What is the range if the value 200 is not present in the data set? So 200 is not there. Then what is the range here?
30.
30. The highest number, it is 50 there. 50 minus 20, the answer is 30. That is what the range. That's what the range there. Okay. Clear? You got it. Then if 50 is replaced by 150, what will be the range?
130.
Listen, the 50 is replaced by 150. Now data changed into 20, 30, 40. Next is 150. Next data is 200. What is the answer?
180.
180 only. No need of a confusion there, right? Because the answer is L minus S. If this data, another data is within these numbers, it is changing or not changing also, the now answer will not change, right? Clear or not? That is 200 minus 20 only, 180 only the answer. Clear? Clear? Okay, so just to keep that idea in your mind. So the dispersion is small. We can say that there is no much differences between these data. Clear? It's a small number. The dispersion is a large number. Definitely, we can say that there is a huge differences are there between these data. Clear? That idea clear? That's what we are using range. Okay, to find out the dispersion. Okay, difference between the data. Okay. So range is, next comment here, range is unduly affected by the extreme values. It is not based on all the values. Okay. So range is related with the extreme values, the small one and the highest one, large one. It is not based on all the values. As long as the minimum and maximum values remain unaltered, any changes in other values does not affect the range. Clear? So the values between the smallest number and the highest number, if it is unaltered or altered, changed or unchanged, it will not create any problem for the answer. Clear? Okay, that's what here 50 is replaced with 150 also. Answer is not changing. Answer is not changing. The same answer because R is L minus S. R is L minus S. R is equal to L minus S. Clear? Okay. It cannot be calculated from open-ended frequency distribution. So range cannot be calculated from an open-ended frequency distribution. We will discuss that. Okay. Now, withstanding some limitations, range is understood and used frequently because of its simplicity. So very simple to find out the dispersion, right? Right? Okay. So I will give a number for you people. You want to find out the dispersion, right? Write down. Okay, find out. What is the range here?
So we get negative value.
Negative value. No chance for that. No negative numbers are here.
One zero one one.
Of course. That's the last number, right? 1011. 1011. Because that is the highest number. And what is the smallest number here? It is 0. It is a 0. Right? Clear? So simple to find out. There is we don't want to use the 6th or 7th senses to understand this, right? Clear? So 1 minute. Yeah, Karthik also sent the same answer. Okay, so no worries in that. Easily you are able to find it. So it's a simple way, right? So negative values are there, means you should calculate as per that. If negative values are there. Okay. Next one, Used, sorry, notwithstanding some limitations, range is understood and used frequently used of its simplicity. For example, we see the maximum and minimum temperature of different classities almost daily on our TV screen. So temperature variation, the maximum temperature and the minimum temperature and the average temperature, right? Right, always we are able to see this kind of things in the televisions after the news there, right? Okay, TV screens and from judgments about the temperature variations in them, and the people are able to predict, okay, the temperature variation, minimum and maximum temperature. Okay, next one, open-ended distributions are those in which either the lower limit of the lowest class or the upper limit of the highest class are both are not specified. It's called open-ended. Okay, the class interval, the lower limit and the higher limit will not be specified. So that kind of informations are there, data sets are there, we are unable to find out the range because we don't know the lowest one and we don't know the highest one. All right, clear? So lowest data and highest data is necessary. Okay, so collect data about it. So there's an activity for you people, leave it. Now we are moving to the next one here, quartile deviation. So the range is clear, the range is clear for you, right? We are able to find the range simply. Okay, so different methods also are there. We are going for the next one here. It is a quartile deviation. Already we studied a quartile deviation the previous class, previous lesson, right? Quartile deviation, dividing the entire data into 4 groups, right? Q1, Q2, Q3, Q1, Q2 and Q3, right? Then we are able to find the Q1, Q2 and Q3 by using different equations and formulas, right? So the presence of even one extremely higher or lower value in distribution can reduce the utility of ranges as a measure of dispersion. Thus, you may need a measure which is not unduly affected by the outliers. In such situation, if the entire data is divided into 4 equal parts, so huge number, we are dividing that into 4 parts, each containing 25% of the values. That's what a quartile deviation, right? Okay, we get these values of quartiles and median. You have already read that in chapter number 5. We learned that. We know how to calculate it. Okay, the upper and lower quartiles Q3 and Q1. Okay, here upper quartile is a Q3 and the lower one it is a Q1. Okay, are used to calculate interquartile. So Q3 minus Q1 is the interquartile Q2. Okay, so interquartile range is based upon middle 50%, middle 50% of the values in the distribution and is therefore not affected by the extreme value. So the middle, Q2 is not affected by the extreme values because it is the middle, only 50% is located in that value there. Half of the interquartile range is called the quartile deviation, QD. Okay, half of the interquartile is basically termed as the interquartile QD. Interquartile QD. So QD is equal to Q3 minus Q1 divided by 2. Clear? Underline that. Interquartile range is based upon middle 50% of the values in the distribution and is therefore not affected by the extreme values. Half of the interquartile range is called quartile deviation. Half of the interquartile range is called a quartile deviation QD. QD. Thus QD is equal to Q3 minus Q1. Q3 minus Q1. Okay. Next one. QD is therefore also called a semi-interquartile range. Other word for QD is a semi-interquartile range. Semi-interquartile range. So we are going for a calculation here. Calculation of range and QD for ungrouped data. So we are going for 2 different types of calculation. One is for the grouped data and then for ungrouped data. Ungrouped data. Okay, so calculate the range and QD of the following observation: 20, 25, 29, 30, 35, 39, 41, 48, 51, 60, and 70. Clear? What is the range here? What is the range? R is equal to L minus S. So what is the range here?
50.
What? Aditya?
50.
50. Okay. 70 minus 20, 50. 70 minus 20, 50. So the highest number it is 70, the largest value, and the smallest value it is 20 here. So the answer is 50. For QD, we need to calculate the values of Q3 and Q1. So to find out the quartile deviation, we want to find out the Q3 and Q1. Again, we know that if you want to find out the quartile deviation, first of all, want to find out the number. How many are there? How many observations are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? 11. Okay, keep that in your mind. Again, we want to divide that into 4 groups. Clear? So Q1 equation, we know that Q1 is always n plus 1 divided by 4. So Q1 is equal to, what is n here? 11 plus 1 divided by 4. So answer is 12 by 4, right? Yes or no? So answer is 3. Clear? So 3, the size of the third value. 3. So the size of the third value. What is the third value here? 1, 2, 3, 29. Clear? So Q1 is 29, right? Yes or no? We studied that in the last chapter, right? Any confusion here? Okay, so that is 29. Okay, so as the value are already arranged in ascending order. So already the total data is arranged in the ascending order. If it is not so, it is our responsibility to arrange that in the ascending order, right? Yes or no? You should do that. Okay, so Q1 is the size of the third value, that is 29. What will we do if these values are not in an order? What we want to do? The values are not in order. What we want to do? We want to construct, or we want to rearrange that in a ascending order, right? Clear? Okay, then only the answer is a correct one. Similarly, Q3, the size of, okay, so Q1 we know that n plus 1 divided by 4. N plus 1 divided by 4. Coming to Q3, equation is changed into 3 multiplied by n plus 1 divided by 4. Clear? 3 n plus 1 divided by 4. So Q3 is 3 into, what is n here? What is n here? See, n, what is that?
11.
11 plus 1 divided by 4. Okay, so Q3 is equal to 3 into 12 divided by 4. So what will come here? What is the answer here? No answer.
9.
36 by 4, 9. Okay, so 36 divided by 4. Answer is 9 here. Answer is 9. Come back. Okay, so that is ninth value. Ninth value. So we got 9. So go back to the ninth value. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 51. 51. So Q3, it is 51. 51. So we got Q1 is equal to, what is Q1 here? What we calculated? 29. And Q3, the ninth value, that is 51. All right, 51. So 2 data we got already. Q1 is ready, Q3 is ready. Okay, next activity, you want to find out the QD. So what is the equation for find out the QD? Quartile deviation. Q3 minus Q1 divided by 2, it is 51 minus, Q3 minus 29 divided by 2, answer is 11, right? Got that? Got that? Okay, so I'll give you just a simple data for you. You want to find out. Okay. So going forward on. Okay, do it. Fast, fast, fast. 8, 4, 2, 10, 25, 15, 28, 37. Completed. What is the first step here? What is the first step here? Definitely arranging this data into ascending order. So do that. For doing so, we can start like this. Okay. 2, 4, 7, 8, 10, 15, 25, 28, and 30, right? Got? They're correct or not? Okay, 2, 4, 7, 8, 10, 15, 25, 28, and 30. The total number n here. What is the n here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So n plus 1, that is 10. N plus 1 is 10. So going for Q1, answer is n plus 1, 10 divided by 4. So 2.5. So if 2.5 means what do you want to do? Already learned an equation in the previous class, remembering that? Just check it and tell me in the next class. I'm going to wind up the session now. Okay, if a fraction is there, decimal number comes, what do you want to do next? That we learned in the previous chapter, all right? Just check it and tell me the answer in the next class. Okay guys, bye. Thank you.